In this point 4, we are going to talk about the scientific revolution that took place in the 17th century. If you remember, when we talked about the Renaissance, we mentioned the change in mind, and how some of the Renaissance men and women started to be curious about what they had around, and they tried to understand the things that existed, that happened in the world, and not just trying to separate a little bit from religion. But it's really in the 17th century, and we have like inventors and like people who of certain nature started to write books about it. But it is really in the 17th century when what we call the scientific revolution takes place. In this century, across Europe, like with a system of universities and academies already established, and like a very well-functioning printing press and exchanges of knowledge from like between far distant places, we start seeing that like the products of what had started in the Renaissance started to bloom, and we start having some of the major scientific discoveries that are still very important for science today, in mathematics, in physics, in medicine. So in this period, we can relate very closely the advances in science and the advances in philosophy. Yeah, so there were two movements, or two lines of thought developed by two philosophers that are essential for us to understand why and how this scientific revolution occurred at this moment. So the first one is empiricism, en español, empirismo. And empiricism was like a philosophy formulated by English philosopher Francis Bacon. And as the word says, he says that knowledge comes from experience, from sensual experience, from the senses. So only from the things that we can see, we can touch, we can taste. This is important. Yeah. So like he tried to separate from, for example, the knowledge that the church stated through faith. Yeah. So there was a huge difference there. And he developed for the first time, I mean, there had been some previous ways of doing this, but he established what we call the scientific method. So this scientific method or experimental method, in which you, like a scientist, observes nature and then creates an hypothesis, and then makes experiments, so things that you can measure objectively, and so carries out these experiments, and then demonstrates if that hypothesis is right or wrong. And in both cases it's valid, because if it's right, you can demonstrate that and create a law of nature, and if you're wrong, then you understand that that is not your hypothesis, so you have to remake your hypothesis into a new one. So that is the first philosophy movement that is important to understand the scientific revolution of this period. And the second one is rationalism. And we owe this to another philosopher, in this case a French one, that was René Descartes, or in Spanish we usually call it Descartes. Yeah, so he defended actually that something that in theory sounded very different, because he, as the word says, rationalism or racionalismo, he defended that the only way of acquiring new knowledge was through reason. Yes, so only our intellect, our reason, could help us to understand the reality that we had around. This famous quote in Latin, cogito ergo sum, that means I think, therefore I am. En español, pienso, luego existo. And although these two theories, the empirist theory of Bacon and the rationalist theory of Descartes might sound opposite. In reality, both together help to understand how scientists started to realize that it was only through their experience, but at the same time by applying the reasoning to all that sensorial information that they had around, that they could finally establish and demonstrate the laws of nature, how nature worked. So now let's see some examples of some relevant scientists. Scientists of the 17th century. Just a reminder of Copernicus, that had managed to oppose the church and on the theories of the church by stating that the universe was centered in the star, in our star, in the sun, and in other stars. And for the first time, he challenged the concept of circular orbits and just tried to somehow relativize the importance of the Earth, just stating that the Earth was no different than any other planet. And then now in the 17th century, we see Johannes Kepler, who studied the movement of the planets, and he determined the mathematical formulas, and he observed that those statements by Copernicus of challenging the orbits, the circular orbits, he demonstrated that were elliptical, and also that planets did not move at uniform speeds in their orbits. So this widened the knowledge of astronomy. This is one of the strengths of this century, astronomy and physics. And probably the most famous of these astronomers were Galileo Galilei, one of the early practitioners of experimental method that we mentioned, Francis Bacon. And he developed a mathematical formula that is going to be important for other discoveries later, of the acceleration of falling objects and of the law of inertia. He also made great advances using the telescope that helped to better observe the universe. And he challenged the physical categories of form and matter. And then we have Isaac Newton, maybe probably the most relevant physicist of his century, and whose theories are still you still study nowadays. And he learned from other scientists of his moment, which gives us a good example of how he incorporated other knowledge. And he learned from these two scientific methods that we mentioned in the first part of the video. Yes, so the one that was experimental or inductive, and the rationalist or deductive. He tried to, for the first time, he tried to determine a series of universal, natural laws that determine everything that occurred in the universe, not only in the Earth. Yeah. So obviously we know that the most relevant was his law of gravity, but he stated a series of very important laws in physics. So obviously there are many more scientists in many other areas, but I just wanted to give you some few examples. So now you will have to do some research on your own and prepare this week's activity.